Our goal after this little session here is to make sure you know the difference between set notation and interval notation when you're writing out domain and range. We'll look at all of the examples in set notation, and then we'll look at all of the examples in interval notation. Recall that we can represent relations in many different ways, and you have to be able to write domain and range from each of those ways. We have ordered pairs, we have table of values, we have equations, we have graphs, and the graphs can be lines or they can be curvy shapes, they can be joined, not joined, and finally we have mapping diagrams. The simplest way to think about domain is think of the input. Remember, on a graph, the input is along the horizontal and the output is along the vertical axes. If you're given a list of points, it's easy enough to write out the domain. -2, 1, and 3 for domain. -1 and 4, and we don't need to repeat numbers that appear twice. And I think what I'm going to do is change this Y to the blue color, and then we'll keep that all the same throughout the examples. The range are all the Y values. All right, so purple and blue. I got it. Domain we list as -3 and 5. Range we list as 0, 1, and 4. If you notice, I've been using squiggly brackets. That means the set. And I'm giving you the heads up here. Set notation looks like this. Domain and range are a little tricky here for this type of equation because we don't really have a picture of what it looks like. So I just want to pull up Desmos and show you what this looks like. It's a graph that you'll see later on in future courses, but I thought it would be kind of nice to show it now. Here's the y is equal to x squared plus 3 graph, and it's a continuous curved shape where the lowest point is on the y-axis, and this point here is a 3. We can see it from the equation right there that it's 3. All of the y values are bigger than or equal to 3. I want to write out the range first, the y values. All of the y values are bigger than or equal to 3. Now it's important because that line was a continuous line from 3. We need to be precise in writing out the range. And how we do that is we say y is an element of the reals. Remember this picture? The real numbers includes everything. So if you're going bigger than or equal to 3, you're including all of the numbers, all of the irrational numbers and the rational numbers. Oh, pi is included because it's 3.14, etc. So all of the real numbers are included. Now how we say that is y is an element of the reals. And of course you don't want to write all that each time, so you could write it as y is an element of the reals for short. Because this picture goes on forever and ever, you could plug in any value for x and it looks like it goes up and stops in the x direction, but it doesn't. It actually goes all the way negative and all the way positive to infinity. And how we say that is x is an element of the reals. Here's a line and there are arrows on either side. If you look from the origin and you walk in the x direction, you'll see that line goes on forever and ever. And the same thing, if you walk in the negative direction, you'll go on forever and ever. Therefore, the domain would be x is an element of the reals. Now the range, if you start walking here and go, it's going to go up forever, and it's also going to go down forever. Y is an element of the reals. For domain, we'll start walking from -2 on and stop at 2. How we write that is we go from -2 to 2. We're dealing with the x's because it's domain, and it's less than or equal to, less than or equal to, because we want to say that all of the x's are bigger than or equal to -2, and all of the x's are less than or equal to 2. And again, we're going to need that x is an element of the reals because all of the points are joined up. The range goes from 0 all the way up to 4. We write 0 is less than or equal to y, which is less than or equal to 4, and y is an element of the reals. Mapping diagram, we know we have input and output, the x values versus the y values. We can say that the input or the domain is 3, 4, 5 exactly, and the range is -2 and 1 exactly. We need to be precise in writing domain and range because it depends on each situation. In the real world, we can be looking at something like time along the horizontal and maybe height along the vertical. You could be studying the height of a plane that's going from flying down to the ground. And if you're doing that, you can analyze the input of time, how many minutes it takes for an airplane to get down to the ground. You can say the time is the input, height is the output, and you don't skip heights. You don't go from 1,000 meters right to 500 meters and then right to 0. You go from 1,000 and you hit all the numbers in between. You hit all the heights in between till you get to 0. Therefore, it's important to be precise in how you label domain and range. The symbols you'll need, here we have a closed circle, which means you include the value. An open circle means you do not include the value. We have an equal sign and a not equal sign. Less than, greater than, less than or equal to, greater than or equal to. Set notation, you're going to use squiggly brackets. And interval notation, you will use 2 sets of brackets. The round set means you do not include the value, and the square brackets mean you include the value. And you can have a combination of these as well in interval notation. Again, here we will include the value, don't include the value, don't include the value, include, don't include, and include, include, and don't include. Let's review the examples we just did and see if we can write these 2 types of notation. Domain and range are written in set notation for ordered pairs. Domain and range are written in set notation for table of values. Set notation uses this, but in just a little more detail. We use the squiggly brackets and we say x is such that x is an element of the reals, and then close the brackets. Set notation for range would be squiggly bracket, y is such that y is bigger than or equal to 3, comma, y is an element of the reals. Set notation for domain would be squiggly brackets, x is such that x is an element of the reals. And for range, we would write y is such that y is an element of the reals. For a circle, set notation would be domain as x is such that -2 is less than or equal to x, which is less than or equal to 2, comma, x is an element of the reals, close the bracket, and range would be y is such that 0 is less than or equal to y, which is less than or equal to 4, comma, y is an element of the reals. Finally, mapping diagrams are written in set notation. Now let's look at interval notation for each. The domain for interval notation would be, it's quite simple. We include -infinity, comma, infinity, round bracket. This goes on forever, so we use a round bracket. And the range for interval notation would be we include 3 and then we go to infinity, round bracket. Include and then round bracket goes forever. For a line, interval notation would be domain is equal to -infinity, comma, infinity, close the bracket, and the range would be same thing, -infinity, comma, infinity. Interval notation for a circle, the domain would be, we're going from -2 all the way to 2. We use square brackets because we're including both points. And the range goes from 0 to 4. We include both of those points. Mapping diagrams are only written in set notation. And there you have it. We've written domain and range in more detail. We've used set notation with squiggly brackets, and we've used interval notation with round and square brackets. Sorry for throwing in another symbol for the interval notation, but we should add positive infinity and negative infinity to our symbol list.